So today we'll be covering Harvester, which is an HCI solution, K3s and Traefik, but also we will cover a little bit of Rancher and the integration with Harvester. And I will be explaining how all the pieces fit together as we are advancing on the webinar. So first things first, my name is Andres Valero. As you can notice, I have a strong Spanish accent. So I'm from Spain, based in Valencia. So KubeCon was in my town last week. And my background basically is a little bit weird because most people start doing technical stuff and some of them then move to sales. So I went the other way around. I started in sales, I moved to a consultant company, then I was a solution architect, and now I work in marketing. So I did a little bit of everything. In here, you can find also my social media in case you want to be in touch. And before starting, I just saying that my voice and my throat are in a terrible state. So I'm sorry if I cough or if I run voiceless in the middle of the session. So let's start. So first of all, a little bit of how are things actually in the market. So infrastructure landscape is changing rapidly, is evolving in a manner that never did. Containers are growing and growing. So Forrester says that by the end of 2022, 60% of enterprise will be leveraging containers on the cloud. But also, if we look to older technologies, let's say, like virtualization, the virtualized workloads are now mature, and they are going to be coexisting with containers for a long time, because there will be some applications that are hard to convert into microservices or into containers. There will be workloads that companies decide not to move from virtualization. Sorry. And also the HCI market, so Hyperconverged Infrastructure, is going to be growing a lot in the next 5 years. So Harvester is the foundation of today's talk. So I'm going to start telling you a little bit of Harvester. Harvester basically presents a lot of cloud native technologies into a single API. So it has Kubernetes, it has KVM for virtualization, it has VM management using KubeVirt, persistent storage with Longhorn, Meta CNI with Multus, because at the end, and we will see more later, the VMs will be running on a pod, and the pod will need multiple interfaces to connect to multiple networks, VLANs to be more concrete, and virtual IP to manage by KubeVirt the different IPs inside Harvester. So in case some of you are wondering what is a hyperconverged infrastructure and why it's important, first of all, HCI infrastructure is all software defined. So basically we have compute, storage, and networking all in one, all in a piece of hardware, but software defined. So for instance, usually it incorporates a hypervisor for the VMs, software-defined storage, software-defined networking, and relies on hardware that you usually have already in your organization. What brings this HCI on the table? Basically, it helps operations with VMs, including deployment, lifecycle, management, etc. So it's scalable. It's not only scalable adding more nodes, but as we will be using Rancher as an umbrella that covers everything, we'll see that we can scale also with more clusters on different architectures. Also, it's reliable across environments. It will help our operators' agility. Why? Because basically at being software defined, it will improve and sorry about that, improve automation, and automation can be performed in different manners that we will see later on. Also, cloud integration, again, it integrates with Rancher, and Rancher integrates not only Harvester or on-prem technologies, but also cloud. So we will have a mixture of cloud and, let's say, private cloud. So what's Harvester? It's a hyper-converged infrastructure solution, as we were saying. As anything at SUSE, is 100% open source, no licensing, no hardware fees. Just if you want to use it and you want to have support, hire the subscription. It's built on Linux, Kubernetes, Longhorn, KubeVirt, Multus, or Cloud Native. Basically, the stack is SUSE Linux. It's not exactly SLS. It's a modification of SLS. Then on top of it, we have RKE2, and then we have Longhorn for the storage, KubeVirt, Multus, all the pieces that fit together to deliver something that I think is unique in the market. So you can have HCI solutions. In one side, you have, let's say, virtualization in containers or in pods in other products, but you don't have any more dedicated products with these characteristics like Harvester. So it's production ready. As I already told you, implements HCI on bare metal, is lightweight, software driven, doesn't require any additional hardware, just what you find in your server, and is reliable at edge. And as already introduced, has integration with Rancher for containerized workloads. So what's the idea? The idea is having Harvester and Rancher as a part of our, let's say, journey. You can say digital transformation, IT modernization, whatever buzzwords you like more. But at the end, the idea is, okay, I have virtual machines. In those virtual machines, I have applications. And some of those applications, I want to move them into Kubernetes and running on containers. So in this concrete use case is where Harvester will shine. So speaking about architecture, we will have a node, or for instance, this node. Then we have SUSE Linux, we have RKE2, KubeVirt, Longhorn, KVM. At the end, we have a stack in a node where we can run VMs. And those VMs, remember we were speaking about Multus, will have multiple interfaces, so they can join the management network, but also they can join different VLANs. And what it will be special about Harvester is that relies on Kubernetes, so it will use Kubernetes scheduler, and it will be also taking profit of the namespaces. So isolation, you'll have whatever you expect to have on a virtualization platform like KubeVirt, for instance, but using cloud native technologies, everything is posted in a single API, a known, very well-known API, and everything in a single, let's say, piece of software. Many of you will be by now wondering what are the requirements. So basically, it supports x86 and 64 processors. The minimum is 16 core or more. For instance, I wrote recently a blog post. If you want to take a look, it's on our blog, and I was just in a Ryzen 7 to virtualize or to install Harvester, to be more precise. Memory 32 gigs. Important, the disks. You need fast disk. If you want good performance, you need fast disks. If it's for a lab at home or something, common SSD disk will be more than enough. But if it's production environment, you will look for good disk. The fastest, the better. And same happens with networks. For instance, the minimum says 10 gigs. My lab at home is 1 gig, works amazingly well, no problem at all, but it's a home lab. If you want to use it in production, you want to look for a really fast network. When it comes to deployment, it's super easy. We use an ISO or we can use PXE. So basically, you start with one node, you deploy ISO, an ISO, for instance, you say, okay, this is my first node. I want to create a new harvester cluster. In the process, it will ask some questions. It will generate a token that you will need to add more nodes to that cluster. Why? Because we are using RKE2, so we are using the same process that you will use in RKE2 to join more nodes to a cluster, to adding nodes to the harvester cluster. So at the end, basically, it is shipped like an appliance. So we have operative system, Kubernetes, everything in one single appliance. We install in a node, in a hardware node. And then we say if it's a new cluster or if it's going to be a new node for an existing cluster. Okay, so let's continue. Which is the idea under the hood? So I like this graphic because it's simple. So you can have your different harvester nodes and clusters. You can have Kubernetes clusters running on top of VMs in these harvester nodes. And then you can have, let's say, coexisting VMs with Windows, with Linux, with those clusters. At the end, what we are doing is simplifying the way that we can communicate containers and VMs. So we are simplifying this coexistence we were speaking about. And on top of that, we have Rancher. Rancher is going to be like our umbrella that will provide, and we will see later on the demo, we will provide all the capabilities we need to manage this landscape. And at the end, yeah?
Yeah, do you know, will this only work on SUSE Linux, or is it possible to manage with the Puppet in the OS level as well?
No, it is shipped as an appliance. So the operative system is integrated in that appliance. The operative system is SUSE. It's, let's say, a modification of SUSE Enterprise Linux. It's not exactly SUSE Enterprise Linux, but no, at the moment it's an appliance and you can use that operative system. Well, now use cases that we can cover with Harvester and with Rancher. So we can use it at the edge. Harvester doesn't need to be, let's say, a proper cluster. It can run one single node. So you can use it at the edge. You can use it as a proper cluster in a data center. And in cloud, it doesn't make sense to deploy Harvester in cloud because the cloud providers on themselves are an HCI solution. They are virtualizing compute, network, all their services. Everything is defined probably as code. And at the end, what we have is a Kubernetes API on top of it to speak with, and Rancher will be the tool that speaks with those different APIs, offering, let's say, a hybrid solution. So speaking about, sorry, features, we already spoke that it can be installed using ISO or PXE. We can also use air-gapped environments. We can use proxies. We can use cloud config to inject configuration in the different VMs. We can use also different SSH key injections. We have PNC and serial port to connect to the different VMs. We can use templates, live migration. Remember, we're using the Kubernetes scheduler. So live migration, unless you use some kind of taints and tolerations, or maybe some kinds of labels to define that some VMs you want them to run in concrete nodes. By default, they will be treated as a pod. So they can run on a different, let's say, different host or different node. If a host or a node has problems, the scheduler itself will move, or we can just force it using the live migration feature. We can export images from existing VMs, and also we have Terraform support. And remember, we were speaking about automation. Well, in here, we will have mainly two sources of automation. We can have Terraform, so we can use Terraform provider for Rancher or for Harvester, but also we have Fleet. Fleet is a GitOps engine by Rancher that can help you to manage Harvester clusters or Kubernetes clusters at scale using GitOps. So you have both. You can, let's say, define and work as code. It has built-in monitoring dashboard. So as you could imagine, in any Kubernetes cluster, we will have our Grafana, nice metrics, and I'll show you later. Regarding storage, high performance, block storage, resilient, HA, we're using Longhorn for that. We can also perform backup and restoration of VMs using NFS or S3 buckets. We have hot plug disk, so when you add a new disk, we will detect. And regarding network, we have virtual IP for the clusters, multi-network support, VLAN support, custom SSL. Let's say, despite being a first release, the most important features are all covered. Now, I'd like to introduce Rancher in case some of you don't know it. I've been mentioning Rancher a lot, and maybe someone doesn't know what Rancher is. So basically, Rancher is an enterprise container management tool. It can run on any CNCF compliant distribution. You install it as a Helm chart. It is compatible with different operating systems. So it runs on Kubernetes. If you deploy in one of our Kubernetes distributions, it can run different operating systems, but you can use it like in AKS, EK, whatever. It's low on resource consumption, and as always, open source and flexible. That's kind of our motto here at SUSE, right? And what offers? So single pane of glass for managing clusters in public cloud, on-prem, it doesn't matter where they are running. Standardized monitor and logging tools, application market based on Helm charts. We have our partners market, Rancher or SUSE market, and you can add your own Helm chart repos, so you can offer to your users different. So we can also offer full life cycle for AKS, EKS, and GKE, cluster management at scale, as already told you, with GitOps and Fleet, Harvester cluster management, and support as many providers as you can see here, from AWS to Harvester or DigitalOcean, or even more. So, well, multi-cluster management using Rancher. We've been talking a lot about clusters, and we've been talking about Kubernetes clusters and Harvester clusters that at the end are also Kubernetes clusters. So they can be imported in Rancher. Rancher provides full role-based access control for our clusters. It's able to manage the entire infrastructure, and it can also deliver policies and push updates to our managed Harvester clusters. So it will provide us an extra, let's say, management layer, even though Harvester itself, once installed, it provides you this same UI you're seeing here, but this same UI can be accessed using Rancher also, and you'll see later on in the demo. So the design of the UI, I think it's very good. Why? Because it's really familiar for a VM operator or virtualization operator, it will be really familiar. Some new concepts like namespaces, but VMs, VLANs, these volumes, all the common, let's say, concepts are there in a comprehensive manner. Sorry, I had to stop a little. I'm sorry, but my voice is killing me. Now let's introduce K3s. Remember, today we were talking about building a cloud native platform with Harvester, K3s, and Traefik. So now it's time to introduce K3s. K3s is a Kubernetes distribution that ships in a single binary. It's a very flexible and lightweight distribution. It comes out of the box with everything you can need. So we ship Traefik ingress controller. We will be speaking about Traefik a little bit later. We have out of the box embedded SQLite database for single node clusters, but we can also use external MySQL databases or etcd. I'll show you later a cluster that we will use for today's session that has a complete control plane running etcd. So different CNI plugins for the networking, out of the box is Flannel, Core DNS, service load balance, all what you need. But the most important is that all components are swappable. So you can change or deploy based on what you need or you like best. And as I already told you, it's available also in HA. And why K3s? Because first of all, it's perfect for Edge because it's high available if you want, certified by CNCF, ready for production workloads in resource constrained environments, and even in IoT appliances. It's very low on consumption on resources. K3s is simpler. It's packaged as a single binary, less than 50 megabits. And from it, you can install, update, and let's say manage a cluster. But for me, most important is that runs almost everywhere. So it uses Linux and supports x86, 64, ARM, 32 and 64, and also it supports E390X, so mainframes. So it can run almost everywhere. Now is the time for Traefik. Traefik, it's a reverse proxy and load balancer that makes your life easier when it comes to managing your microservices or your applications deployed in your clusters. It comes out of the box with a powerful set of middlewares, load balancing, API capabilities, ingress controllers. So basically everything you need to manage your services is here. And how it works, the architecture, how it works is I think one of the nicest things from Traefik. So basically, you can perform from the internet different calls to different, let's say, domain and subdomains, and Traefik will handle the encryption if you want, and also will handle that all these services will end connected to the proper backend. Is a web server, a back office, an API server, whatever you need. So Traefik will be like this, the small logo will be controlling all the internet traffic coming in and coming out to your cluster. And this is all regarding the presentation. And now it's time to go to the demo. So here we have our Rancher cluster. And you can see that we have some, some clusters already deployed. This is the main web UI. I'm going to show you a little bit of rancher. I'm going to show you harvester more deeply. Then we will go to this K3s cluster where we have a very simple Traefik service. We will be using the Traefik dashboard for the demo, and we will see how fit all together. So sorry again. So let's start checking our demo cluster. So we can see here the basics of the cluster. So we have 5 nodes. We have 3 control plane. We will see later how we did this, how we can provision these kind of clusters. We have an etcd here. We can check any of the nodes and we can see what's happening, the information, we can see details, configurations, and we can see as YAML. Later on, we'll see that VMs in Harvester can be treated as code. We can get YAML also, and then we can also use Fleet to manage those VMs. But for now, let's check namespaces, sorry, in the cluster. So we have a local namespace, Traefik1. In this case, this concrete cluster, instead of deploying K3s with Traefik included, I deploy the cluster without Traefik, and later on I install Traefik, just to demonstrate that we can be, as we were talking, the pieces are swappable. We can install and modify whatever we need for the management of the cluster. So we can see workloads, we can check here namespaces, all what we have, and we can also copy or download kubeconfig. kubeconfig is already downloaded on my machine, and I'll show you later, but we can also connect from here to the command line. We can do kubectl get nodes, for instance, and we will see our nodes. We have 2 workers, 3 control plane nodes. So basically, we are providing you from here all the tools you need to manage your K3s cluster. But now we are going to move to virtualization management. So we are going to check what Harvester is able to do and what is happening here. So we have just 1 Harvester cluster. Okay, sorry, it looks like it's a little bit slow today. Okay, it is coming, taking its time, but coming. So we can see that Harvester has 3 closes, so the minimum to be a real cluster. We have different hosts with different names, different IPs. Okay, CPU, memory, we can drop down and see more information, see the VMs running on those clusters, the network details, the disk they have. So we can see pretty much all the information we need for the clusters. But in here, in this main dashboard, you can see also, for instance, cluster metrics, VM metric. This is all coming for Grafana. So we can also click and go to Grafana to see those. Okay, we have also events. So what's happening? So someone has been creating, stopping, and deleting VMs. We can see if there are some events with these objects also. So pretty much we have what you would expect from a dashboard in a virtualization platform like KubeVirt or like OpenStack, but in a nicer manner, let's say. So we can check the images we have, volumes, VMs, for instance. We can see in this namespace, Harvester public, we have the VMs of my cluster. And we can, from here, as I already told you, we can use VNC or open a serial console to connect to the VMs, and we can interact to the VMs from here. but we can also inject an SSH key just to be able to connect using SSH. So let's get moving. In here, we can see the volumes, and volumes is a concept that we will be, let's say, used to here in a virtualization platform, but the reality is this is persistent volumes. Those are PVs attached to a pod. So you can use it as your VM storage. And as anything in Kubernetes is also affected by namespaces. So you have different volumes or PVs in different namespaces for different VMs. You can use images. In this case, we have these two images. And you can also use ISOs or raw. There are different cookout 2. So you can use different images. And if you want to deploy a new VM, you can just come here, click on create, and start to, let's say, deliver all the details. The different thing you'll find is you have to select a namespace. So this is the biggest difference maybe. So you can say this, okay, this is VM test 112. You can put any description. You can select and say, okay, I want 2 CPUs. I want 4 gigs of memory. I'm going to use this SSH key to access. You can define volumes, so you can add as many volumes as you want. You can add existing volumes. So when you delete a VM, you can keep or delete the volumes associated to that VM. You can add a VM image, sorry, or you can add a sidecar container also that will act like a disk, but it will be a sidecar container. So there are different features that will help you interact with the VMs. And regarding networks, it's a little bit as always. You can select the network. You can select kind of virtualization for the card. So nothing fancy, nothing different from a virtualization platform. Here is where it comes, let's say, the big difference. So you can use node scheduling, and by default is run VM on any available node. That means I'm going to use Kubernetes scheduler to place my VMs. You can use a specific node, so whatever you want. But if you run a VM in a specific node, live migration obviously is out of the table. You can't use live migration. Or you can use matching scheduling rules. So a VM can run in a specific subset of nodes, and live migration is enabled amongst those nodes, sorry. You can use cloud config, as already said, so you can inject this configuration you need using cloud config. And this is mostly all from the VM side of things without going really into super deep techie things. We can use role-based access. So we have these. The role-based access may be local or coming from Rancher. And in the advanced features, you can have the backups, networks, SSH key, configure cloud config templates that you will configure to inject configurations inside the VMs. You can configure the backups, so you can restore from a backup. So what we talk, in this case, NFS, you could also use an S3 bucket for backups of the VMs. And this is mostly all on the harvester side of things. Now we're going to go back to Rancher and cluster management. So we see we have different clusters. We can import or create clusters from here. For instance, we can explore our cluster. We can, as we saw, take a snapshot, restore on a snapshot, rotate the certificates from here. But in this case, what I'm going to do is create a new K3s cluster, despite we're going to use this one later on. We are going to create a new one so you see how is the workflow and the process on Rancher. So we go to create. And first of all, we are going to find all the options to deploy cluster we have. So we have from Equinix, EKS, Yiki, you can deploy RKey2, K3s, or RKey1, depending on which kind of cluster you select, the mechanism to deploy the cluster is different. For RKey2 and K3s, we're using Cluster API, and out of the box, we support all these providers, including Harvester. But you also have this option here that is custom. So if you select something that is Cluster API based and has a driver for a platform that is not here, you can customize and prepare your own platform to consume from Rancher. But now we are going to click on Harvester because today's session is basically oriented to Harvester. And now we are going to create a K3s cluster. So we are going to call the cluster K3s webinar. You put any description. And the first thing we can see is, this has just one etcd, one control plane, one worker. So this doesn't look good. You can remove etcd, you can remove control plane, you can change here the count. So 3 counts, etcd, control plane plus worker. So this will be a viable option. But we can also create different pools. You see that in here says matching pools. Okay, let's call this control plane. And I'm going to use an SSH user. I'm going to use a namespace, a VLAN, and now I can add a second pool. This will be, for instance, workers. And again, just worker, we can add more, but let's delete this. Let's stick to something fast. So one node machine, okay, in this namespace, using this less image with this VLAN. And here further down, there are more configuration items. So first of all, by default, if you selected in the tab RKey2 K3s, by default, it will deploy RKey2. But now we want to use K3s, that is now in tech preview. Okay, perfect. We selected K3s, and here we can select the system services we want to use. So we can do metrics, traffic, we can install it or not, whatever we want. Member roles by default, since I'm using an LDAP user that is my user, this is what I have here, and this is coming from Rancher. The LDAP connected is in Rancher, and we can add environment bars. We can use etcd snapshot to automate the cron to schedule snapshots from our etcd in case of disaster recovery, labels and annotations, networking, kind of upgrade strategy. So worker nodes, concurrency, drain nodes, yes, no for the control plane and for the worker nodes. So you can pretty much configure everything from here. For now, we are going to create this single node cluster. So now we can go to Harvester, so virtualization management, and we'll see if we go to the VMs that there is a new VM that is popping up. Sorry, here it is. So this is the new VM that is going to go through a process. First of all, the VM has to be provisioned and be in running state. Once it's ready and it has an IP, it will start joining the cluster. In this case, it's going to become a single node cluster. Now we see that we have already a node assigned. We have, sorry, oh my God. We have almost ready the VM. Okay, now it's completely ready, the VM. And we can go to the cluster, and we'll see that now this VM, it's becoming a Kubernetes cluster. So from Rancher, we've been able not just to create a VM, but also to deploy the K3s cluster. And it will keep this process. It will take a few minutes, I don't know, 3, 4, 5 minutes max, until it becomes a fully functional cluster. So let's wait a little bit. Okay, so it finishes the process. And in the meanwhile, you can see here the continuous delivery. So this is basically fleet. So remember, I talked to you about GitOps at scale. So from here is where you can manage at scale. You can add your Git repos, manage clusters, create cluster groups. So you can define, let's say, configurations or deploy applications in a group of clusters. So this is something that you may look into a little bit further in the time. So, okay, waiting for cluster agent to connect. So it shouldn't be long until it's finished. But in the meanwhile, let's move on to our cluster and check our service. So now basically, sorry, I'm going to move to the CLI. I hope you can see the screen. In this folder, I have the kubeconfig file that I downloaded from Rancher. It's already exported, so I can do kubectl get nodes and see the nodes from my cluster. So K3s, 2 workers, 3 masters or 3 control plane nodes. As we were discussing, you can see the different roles. Also, we can get the namespaces and see, for instance, that we have a Traefik namespace. If we get kubectl or kubectl, I think I always call it wrong. Sorry for that. But in the Traefik namespace, we'll see all the Traefik pods. Usually when you install K3s, you'll find them in kubesystem. But since I installed separately Traefik, I decided to install it in a separate namespace. So in this case, you have here, we have one pod for the load balancer in each of the nodes. We can have here also the Traefik main pod. And let's check something. In this folder, I also have something called Traefik dashboard. What I done, since I'm not a Traefik expert and I didn't want to make something super complicated because we already had a lot of content for today, I went, let's say, the easy way. So in here, we are now connected to a VPN, and I defined a private DNS entry that is traefik.susedemo.com. And in the /dashboard, I'll find my dashboard for Traefik. Usually the Traefik dashboard is not exposed for security reasons. So the recommendation is, if you do this, don't do it to a publicly, so a public accessible IP or DNS entry, or use just port forward to see whatever is happening, and that's all. So for now, I created this using this. So an ingress route with the name dashboard. I use one of the entry points that Traefik provides out of the box, that is the web one. So this entry, and basically, if we kubectl get ingress route, we'll see that our ingress route is here, and we can go to our browser and create here, or to create no access to the Traefik dashboard. We can see the entry points that are out of the box defined. So we were connected to the web. And from here, we have all what provides Traefik. We are just using some routers, some services, no middlewares. Okay, but you can use middlewares to improve your experience. You can configure Traefik so it can use TLS encryption by default to your endpoints, and it can, even though you can access or try to access to a AT port or let's say non-secure port, it can redirect you to a secure port. And at the end, what I wanted to show you today is with Harvester and K3s and something like Traefik, and Rancher is optional, but definitely will make your life easier. You are able to, let's say, create a lightweight cloud platform for home, maybe at the edge, in a data center, whatever you want. The idea is that you have all the tools needed to manage the virtualization, Kubernetes, the services, and the endpoints. And this is basically most what I wanted to show you for today.
If anybody has a question for you, where can they reach the SUSE community?
Well, there is the SUSE Rancher community where they can join in. And in there, it's Simon, it's me. There is also Robert Sircia, Luke and Bila, that they are amazing and they can help you. And of course, I'll be myself also around, so we can answer questions. And there is also, if you go to Rancher web, there is a Slack channel you can join. And there are a lot of people that really, they know way more than myself about Rancher and the products, because maybe they've been managing Rancher or Harvester for, well, Harvester not very much time, but maybe Rancher. And it's a community where you can engage, and people are extremely, like in any open source community, extremely willing to help, let's say. So please go or register in the SUSE Rancher community or go to the Slack channel. You will get help for sure.
I am a member of the SUSE Rancher community, and I can agree it's really approachable. I'd also like to invite you, if you have any Traefik questions, to join us at community.traefik.io. We are fairly responsive, and it's a large and growing community of people who are helping each other troubleshoot as well as sharing their neat builds. So feel free to join us at the SUSE Rancher community and at the Traefik Labs community forum. Thank you, everybody. We are going to go ahead and end the video here. You should be receiving a recording of this video and a link to Andres's blog post from me very shortly. And we'll see you at the next one. Bye.
Bye-bye. Thank you for coming.